Hello everyone. Today we are going to look at another interesting LeetCode problem called as time taken to cross the door. So over here we are given n persons numbered from 0 to n minus 1, and they need to pass through a door. Now each person can enter or exit through the door once, and this action takes 1 second. Now basically we are given two input arrays. The first one is arrival, both of size n, and so this arrival represents the arrival time of all the n people, and this is a non-decreasing integer array. We are also given another array called state of size n, and this represents the state of the person. So essentially if the person wants to enter through the door or if they want to exit through the door. So 0 represents the entrance and 1 represents the exit. And finally we need to return an answer array of size n. Answer I is the second at which the ith person crosses the door. Now if there are two or more people who wants to use the door at the same time, then we need to follow few rules. If the door was not used in the previous second, then the person who wants to exit will be given the priority, and if the door was used in the previous second for entering, in this second also the person who wants to enter will go first, and if the door was previously used for exiting, for this second also the person who wants to exit goes first. So basically the last action, whether it was entering or exiting, that action will be given priority in this second also. And if there are multiple people who wants to go in the same direction, the person with the smallest index goes first. Yes, so it's possible that more than two people arrive at the same time, and now we will give preference to the person who has the smallest index in the arrival array. So let's look at this example. We have arrival and state array and the answer array that we need to fill. So here we are maintaining few variables. The variable t, which denotes the next available timestamp at which any person will cross the door next, and so the initial value for this variable t will be the arrival time of the first element, first person, so which is 0 in this case. And this another variable last direction, so which means whether someone has entered, exited, or no one has passed through the door in the last second. Now here note that the last two cases, when someone has exited the door or no one has passed through the door in the last second, are similar, as in both cases we are giving preference to the person who wants to exit in the current second, so its initial value can be considered as 1, following the rule number 1. We are also maintaining two queues, entry queues and exit queue. So basically queue here is a good choice, as any two people with the same arrival time who want to go in the same direction, the one with the lower index will be considered first, as we will be traversing the arrival array from left to right direction. So here the idea is that as we will traverse the arrival array from left to right direction, we are storing the potential candidates which will pass through the door at the time t, and as we come across a person whose arrival time is greater than this time t, we kind of wait, and from these queue we choose the best potential candidate based on the last direction variable. So let's do a dry run. So first we are here, and we know that the last direction so the arrival time of this person is same as the value t, so meaning this person can become a potential candidate in the future for this time t is equals to 0. So we push the person in the queue, we check the state value is 0, we push the person in the entry queue. So note that we are storing the indexes of the persons in the queue and not the original arrival time value. So we store the index 0 over here, and we come to this element. Now here we know that the arrival time is 1, so meaning that this person cannot pass through the door at t is equals to 0. So now we wait over here and we try to find a best candidate from these two queues. So based on the last direction, which is 1, we check the exit queue, but there is no person in the queue. So then we check the entry queue, and the last person here is present over here. So the person is present over here with index is equals to 0. So meaning this first person uh, will go to the door at t is equals to 0, and we remove this person from the entry queue, we change the last direction to 0, and now this next available time becomes 1. So now this person is a good candidate. Is possible, it's possible that this person to go to the door t is equals to 1. So we push this person in the queue. Based on the state, this person will go in the exit queue, the index is 1, and then again we move forward. The value is again arrival value is same as t, so we push the candidate in the queue. So based on the state, we push in the entry queue. So now we move at this element. Now the arrival time 2 is greater than 1, so we stop and then we try to find the best candidate out of these queues based on the last direction, which is 0. So we check the entry queue first. So we know that the person whose index is 2 will pass to the door at t is equals to 1. So we make this value as 1, and then we remove the person. We last direction is will still be 0, and we change this t is equals to 2. So now this person can will become basically will qualify and can pass to the door at t is equals to 2. So we push this candidate in the queue, so its state is 0, so we push in the entry queue, the index is 3, so we push it, and then we come at here, we see that the arrival time is 4, this is 2, so meaning this cannot go at t is equals to 2. We try to find the candidate from over here, and based on the last direction, we check the entry queue, and the element at index 3 is there. So this will the element at index 3 will go at t is equals to 2, and we remove this element from the queue, and then our t will become to 3. So now this is still less than the 4, so we again try to find the potential candidate who will go at 3. So we, based on the last direction, we check the entry queue, but there is no one in the last direction in the entry queue, so we check the exit queue, and there is one person with index 1. So with index 1, the person will go at t is equals to 3, and then we change the last direction to 1. We remove this person and we change this value to 4. Now this has become same as this, so this person will become the potential candidate, and we will push that person based on the state. We will push that person in the exit queue, so the index is 4. Now we have iterated through the array. After we have iterated, there still may be some people in the queue, so what we will do is, based on the last direction is 1, we will first check the exit queue. So yes, there is one person at index 4 which can go at t is equals to 4, so we will remove this person, and we will put the t as 4, and then last direction is still 1, and then we increase t 5, but exit queue is empty. So now we check the entry queue, but it is again empty, so meaning that we have iterated all basically all the people have assigned a time. So now there is one interesting change. So for example, instead of 4, if the value was, let's say, 10, right? So if the value is 10, so if the value is 10, meaning when we are looking at a candidate who will go at 4, and then all the queues have become empty, right? And the next element is coming at t is equals to 10. We know that at t is equals to 4 no one will pass through the door, because 4 is less than 10. So meaning we'll have to change our the value of t to this 10 value instead of 5, because the next time at which any person will cross the door will be 10 and not 5. So yeah, here's an interesting thing. So now let's look at the code. So this is the function time taken. This is the answer vector that we are going to return. Last direction is basically a variable, so it defines in the last second whether has someone exited through the door, no one has passed the door, the value will be 1, and when someone has entered through the door, the value will be 0, as explained in the previous section. And the variable t, which defines the next available timestamp at which the person will pass through the door. Any person will pass through the door. So yeah, the initial value is the arrival time of the first person. And here we have a vector of type q. So basically we have created a vector for two queues. Basically here the size will be 2. Q of 0 will denote the entry queue, and q of 1 will denote the exit queue, so that we can so this 0 and 1 is basically same as the state of the person we have defined. So right, so 0 means the person wants to enter through the door, and 1 means exit. So to make it simple, we have decided to keep a vector of a queue like this. So now we are iterating through the arrival vector. We are saying that if the arrival time of the current person is same as the time t, that means this ith person is basically a candidate for us which can go through the door at a time t. So that's why we are pushing it in our queue based on the state, and we will do it and we are continuing basically. So we'll move on to the next element. So now but an I will come for which the arrival of I will become greater than t, meaning that this ith person will not be considered uh, um, when deciding if the person will pass through the door at the time t, because its arrival time is greater than t. So now here in this, what we are doing is basically out of the two queues, q0 and q1, entry and exit queue, we will define which of the candidate will pass through the door at the time t. So inside this, what we are doing is we are checking if both the queues are empty. So if both of the queues are empty, that means that we have considered all the candidates and there is no one to go at a time t. So at that time we are going to break, and then what we are going to do is we are going to checking if the last direction, so if there is no candidate in the queue based on the last direction which is same as the last direction, then we are saying that we will switch the last direction. So if there is no one in the exit queue, then we will switch our queue to be entry queue. We are changing the last directions like this, and then we are updating the answer of the basically first element in the queue to be the whatever the time t is, and then we are removing the element from the queue and then updating the time as t plus plus. So the t, yeah, but when we do t plus plus, right, we will again check if this t is less than the arrival time of the current person, then we will do it till the time we are able to find a candidate to go at a time t which is still lesser than arrival of I. So we will do it till that time, and after this it's not possible to basically pass any person at a time less than arrival of I. Then we break this, and then we simply push the current person which is I in the queue. And then one more thing we check if that the t has updated, right? So the updated t, if it is still less than the arrival time of the current person, What does it means? It means that no one can pass through the door at a time t. So what we are doing is we are updating the time to be arrival of I, and updating the last direction because no one has passed through the door in the last direction. So if you just think about it, so for example, if our array is arrival array is 1 comma 10, right? State doesn't matter in this case, but let's take it 0 comma 0. So we know that, let's say the person 1, this person passes at t is equals to 1. So now t value becomes 2, and we know that this 2 is less than 10. So we know that the next person that is coming at t is equals to 10. So that means the next value of t will become t is equals to 10, right? Because no one can pass through the door before than this. So we simply update the value of t like this, and then we update the last direction to 1 because at t is equals to 9 no one has passed through the door. So this is what we are doing over here. Similarly, like we will iterate the entire array, and after we iterate the entire array, we just check if our queues are empty or not. So basically if there might be still some indexes in the queue, so based on the last direction, whatever the last direction is, we check that queue first, and then we assign time like this to all the elements in the queue, and then we update our last direction again, and then check another queue. So if we think about the time and space complexity, so here so if we look at this this inner while loop, right? In this every iteration we are removing some element from the queue. So if we look at the overall time complexity of this for loop and this while loop, it comes down to order of n, and space complexity is also becomes order of n because we are creating a vector of answer which is of size n, and the queue can also have maximum of n elements. So like this, so both space and time complexity becomes order of n.